We begin right triangles with something called the geometric mean. The geometric mean is the altitude of a right triangle. We call it the mean because it is the middle number that gets repeated in the denominator of the first ratio and the numerator of the second ratio of a proportion. What happened is that the altitude drawn on a right triangle to the hypotenuse divides the triangle into two smaller right triangles, and by doing so, the three triangles, the original large one, the one to the right, and the one to the left, are all similar. This means that all their corresponding angles are equal, and corresponding legs are proportional. Let's do some examples. If the altitude of a right triangle is 8, then the geometric mean in the proportion of the other sides is also 8, and controls how large the other sides will be. If the horizontal side of the left triangle is 10, then the horizontal side of the right triangle is 6.4. Why? Because 8 times 8 is 64, and 64 divided by 10 is 6.4. That is what the altitude does when it becomes the geometric mean. Looking at it backwards, the geometric mean may also be treated as the square root of the product of the two horizontal sides of the two smaller triangles. If this horizontal side is 5 and this one 20, their product is 100, and the square root of 100 and the altitude is 10. Again, because the geometric mean carries the same two numbers. So knowing the size of the geometric mean and of one horizontal leg in one of the smaller right triangle is important. Notice how they change as the size change. Architects and engineers that design trusses for roofs keep the geometric mean in mind, for the geometric mean controls not only the height but also the length and angles of the trusses. Okay, another example. What is the altitude of an isosceles right triangle if the hypotenuse of the triangle is 50 centimeters long? An isosceles triangle is defined as one that has two equal sides. Therefore, the altitude of the triangle must break the hypotenuse in two equal parts of 25 each. 25 times 25 is 625, and the square root of 625 is 25. The altitude is 25 also. It makes sense, because an isosceles right triangle is half of a square, and the hypotenuse of a right triangle is the diagonal of the square. One last example. The altitude of triangle ABC is 45. If side CD is 75, how large is the hypotenuse? If the altitude is 45, we multiply the geometric mean. 45 times 45. It is 2025. 2025 divided by the known side 75 is 27. AD is 27. So AC, the hypotenuse, is 75 plus 27, or 102. Let's review the geometric mean. The altitude of a right triangle is the geometric mean of the proportion that defines the other sides of the three triangles formed.